Good morning, ma'am. I'm B. Tejaswani from this ECE department, first year. My roll number is 234G1A04B8. Today, my topic for the presentation is solve x square of z minus y into p plus y square of x minus z into q equals to z square of y minus x. This equation involves variable x, y, and z along with coefficients p, q. It is non-linear equation involving squares of the variables and their differences. Understanding this equation requires a deep dive into algebraic manipulation. Begin by expanding the terms on both sides of the equation. Group the terms involving x, y, and z separately. Factor out the common terms to simplify the equation further. Analyzing the coefficients p and q. The coefficients p and q plays a crucial role in determining the solutions of the equation. Different values of p and q may lead to unique solutions or no solutions at all. Experiment with the various values of p and q to understand their impact on the equation. Identifying patterns in solutions. Explore patterns in solutions by analyzing the relationship between x, y, and z. Look for the common factors or multiples that simplify the equation. Consider the implication of navigation or fractional solution in the context of the equation. Geometric interpretation of the equation. Visualize the equation geometrically in terms of the three-dimensional coordinate system. Understand how the equation represents the relationship between points in the space. Explore the geometric implications of the equation for the different values x, y, and z. Solve the equation using substitution. Utilize the subtraction technique to simplify and solve the equation. Substitute variables with known values to reduce the equation to solvable form. Check the validity of the solution obtained through substitution by plugging them back into original equation. Exploring special cases and expansions. Investigate special cases where the equation simplifies or leads to unique solutions. Identify expansions or scenarios where the equation may not have any real solutions. Consider the implications of infinite solutions or non-integer solutions in the coefficient. Exploring special cases and expansions. Investigate special cases where the equation simplifies or leads to unique solutions. Identify expansions or scenarios where the equation may not have a real solution. Consider the implications of infinite solutions or non-integer solutions in the specific cases. Applications of the equation in mathematics. Explore the applications of this equation in algebra, geometry, and other mathematical fields. Investigate how similar equations are used in real-world problems and modeling scenarios. Connect the equation to broader mathematical concepts and theories of the deeper understanding. Advanced techniques for the solving nonlinear equation. Apply advanced algebraic techniques such as completing the square or using geometrical identities to solve the equation. Utilize numerical methods or computer software to find approximate solutions for the complex cases. Collaborate with peers or seek guidance from experts to tackle challenge aspects of the equation. Conclusion and further exploration. Summarize key insights and findings from analyzing the equation x square of z minus y into p plus y square of x minus z into q equals to z square of y minus x. Encourage further exploration into related equations and mathematical concepts. Emphasize the importance of perseverance and creativity in solving complex mathematical problems. In this slide, we see the problem. Solve x square of z minus y into p plus y square of x minus z into q equals to z square of y minus x. Given equation x square z minus y into p plus y square x minus z into q equals to z square y minus x. The above equation is compared to the following equation. P into P plus QQ equals to R. Write the auxiliary equation. Auxiliary equation of above equation is dx by P equals to dy by Q equals to dz by R. Substitute P values in the below equation. Dx by x square of z minus y equals to dy by y square of x minus z equals to dz by z square of y minus x. Let L, M, N equals to 1 by x square, 1 by y square, 1 by z square. LP plus MQ plus NR equals to 0. It is of the form LDX plus MDY plus NDZ equals to 0. Dx by x square plus dy by y square plus dz by z square equals to 0. By integrating both sides, integral dx by x square plus integral dy by y square plus integral dz by z square equals to C1. We get 1 by x plus 1 by y plus 1 by z equals to C1 as auxiliary equation. This is the continuation of before slide. Now choose L dash, M dash, N dash equals to 1 by x, 1 by y, 1 by z. L dash P plus M dash Q plus N dash R equals to 0. It is of the form L dash dx plus M dash dy plus N dash dz equals to 0. 1 by x dx plus 1 by y dy plus 1 by z dz equals to 0. Integrating above equation, we get integral 1 by x dx plus 1 by y dy plus 1 by z dz equals to C2. Integration of 1 by x is log x, integration of 1 by y is log y, integration of 1 by z is log z. Substitute these equations, we get log x plus log y plus log z equals to log C2. Log x, y, z equals to log C2. X, y, z equals to C2. The general solution is phi of 1 by x plus 1 by y plus 1 by z, x, y, z equals to 0.